Welcome to today's video. This is a question that I already solved and I posted on my Facebook status, but one of our friends asked for a video solution to get a clear understanding. So like he did, if you see any question on my status and you like to get a full understanding, you could clearly state, and I won't mind, I will do a video solution for that question. So let's dive into this. So if you are the one that replied to the question, here is your solution, a video solution. So the question says we should show that the sum from n is equal to 1 to infinity or 1 all over, parenthesis will be n plus 1 inclusive all square is equal to 1 over 6, parenthesis will be pi square minus 6 encloses. So this is very simple. First of all, before getting into this question, I want to remind you of a very famous function that I use. It's the Riemann Zeta function. It says that the sum for n equals to 1 to infinity or 1 all over n squared is equal to the zeta of 2. So this is n squared, that's why we are saying zeta of 2. We could generalize it by just saying to the s. So it will be your zeta of s. So this is the function I use to solve this question. So now let's dive in. So the first thing we're going to do is to expand the sum n equal 1 to infinity or 1 all over n plus 1 encloses all square. So this will be equal to, we plug in 1 because it starts with 1. We plug in 1. 1 plus 1 is what? 2. And we have a 2 square. So we have 1 all over 2 square. We say plus. When we plug in 2, we'll have 2 plus 1 is 3. And we have a 3 square. So we have 1 all over 3 square. Plus, we plug in 3, we have 1 all over 4 square plus dot 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 dot. This will go on forever. So how can we get closer? How can we get to the Riemann Zeta function? Now if we try to expand the Riemann Zeta function, if we plug in 1, we'll have 1 all over 1 to the s. If we plug in 2, we have 1 all over 2 to the s. When we plug in 3, we have 1 all over 3 to the s. We plug in 4, we have 1 all over 4 to the s plus, and this continues forever. So if you compare this and this, it means that our sum here starts with what? 2. It means that 1 is missing. If you compare this with the Riemann Zeta function, it means that this 1 is missing from here because we start with what? 2. So it's very simple. The only thing we can do here is to add 1 and subtract 1. When you're adding 1 and subtracting 1, it's almost like you are adding 0. Yeah. So we can say that this sum from n is equal to 1 to infinity of 1 all over n plus 1 inclusive all square is equals to, we can say 1 all over 2 square plus 1 over 3 square plus 1 over 4 square plus dot 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 to infinity. Now, so let's add 1 and subtract 1. So we have the sum from n is equal to 1 to infinity of 1 all over n plus 1 encloses all square. You ready to write? It's just equals to 1 all over 1 square. We have added 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square plus dot 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 up to infinity. Now we have to subtract 1 over 1 square, so that this 1 over 1 square and 1 over 1 square is just what? A 0. So now what can we do? If you observe the first portion, it is exactly the Riemann Zeta function. So now we will have the sum from n is equal to 1 up to infinity of 1 over n plus 1 encloses all square to just be equals to, this will be the sum from n is equal to 1 to infinity of 1 all over n square, but what? Minus 1. Because 1 over 1 square is just what? 1. So if you look at this, this is exactly the Riemann zeta evaluated at what? 2. In place of s, we have 2. So the sum from n is equal to 1 to infinity of 1 all over n plus 1 encloses all square is equal to the zeta of 2 minus 1. Now, what is the zeta of 2? The zeta of 2, for time's sake, I will just give you the exact value of the zeta of 2. So you can comment below. Maybe in another video, we can prove that the zeta of 2 is equal to the value I'm about to give. So the zeta of 2, the Riemann zeta of 2 is just equals to pi square over 6. This is the zeta of 2. So it means that our sum now from n is equal to 1 to infinity of 1 all over n plus 1 all square is equals to pi square over 6 minus 1. But how is this equals to this? It's very simple. All we need to do is just to factor out 1 over 6. Open a parenthesis. When you take 1 over 6 from here, you have just pi square. And in order to get 1 here, it means you have to minus 6. So that when you do 1 over 6 times 6, you just get what? 1. So therefore, ladies and gentlemen, fellow mathematicians, we have proven that the sum from n is equal to 1 to infinity or 1 over n plus 1 all square is equal to 1 over 6, parenthesis open, pi square minus 6, it closes. So please do yourself a favor, do us a favor to subscribe to our YouTube channel, follow us on Facebook, on Instagram, on TikTok. Yes, we are now really that social media type, but try to follow us and we'll be coming up with more math videos. Thank you very much. Once again, I'm Guru Joe.